All right, for this example, we're given this equation, y squared minus x squared minus sine xy equals 0. And we're asked to find dy dx. So first I want to do this the way that we would have done it in single variable calculus. So we're just going to go through and use implicit differentiation here. So this is going to be 2y times dy dx. Minus 2x minus cosine xy, and then we're going to have to use the product rule for xy. That's going to be x times dy dx plus just y. And that's going to be equal to 0. All right, now let's get our dy dx terms together. It's going to be 2y dy dx minus x cosine xy times dy dx. And that's going to be equal to, if we move that 2x over, let's move this negative y cosine xy over. So it's going to be positive y cosine xy. All right, now we can factor this dy dx out of here. 2y minus x cosine xy is equal to 2x plus y cosine xy. And then if we divide both sides by this will go away and we get dy dx is equal to 2x plus y cosine xy divided by 2y minus x cosine xy. And that's going to be our answer. And I'm going to box that in. And now I'm going to go back and I'm going to do it the way that we learned in this unit and see if we don't get the same answer. So, all right, we're told that what we want to do with this is we want to take all of this that's equal to 0, and we want to call that capital F of xy is going to be equal to y squared minus x squared minus sine xy. So now instead of a function with an independent and a dependent variable, we've created this function of two independent variables. And so now we're told that dy dx is equal to negative capital F sub x over capital F sub y. So it's the partial derivative of f with respect to x divided by the partial derivative of f with respect to y, and then we take the negative of that. So the partial derivative of f with respect to x, if we hold this constant, that's just going to be 0. Derivative of negative x squared is negative 2x. This is going to be negative, and let's put this in parentheses. So this is going to be negative 2x. And then minus, this is going to be y times the cosine of xy. And then the partial derivative of f with respect to y, this is going to be 2y. That's going to be a 0. And then this is going to be negative x cosine of xy. And so we can see that now if we distribute that negative sign, this is going to be 2x plus y cosine xy divided by 2y minus x cosine xy. And you can see we got the same answer, and we got there quicker than we did through this implicit differentiation. This is going to make things easier for us. It's kind of a cool formula.